Beneath the deadliest deserts on Earth, rivers still flow in total darkness. These are not myths, but the forgotten masterpieces of ancient hydraulics known as underground aqueducts. From the vast Persian Empire to the remote frontiers of Rome, these hidden channels were the secret weapon that turned barren sand into thriving cities and fertile farms. By the end of this journey, you will understand how these silent networks built and sustained entire civilizations against impossible odds. We will uncover how they were engineered without modern tools, why some societies chose to vanish into the earth to find water, and what crucial lessons their stones hold for our own thirsty future. What does it truly mean to build a legacy that lasts for thousands of years? The desert does not give up its water easily. In landscapes where the sun reigns supreme, rivers vanish into the air, and lakes retreat into memory. Survival becomes a matter of profound ingenuity. For the early peoples of Persia and Arabia, the challenge was absolute. Their world was one of extremes, where fertile valleys were rare gems scattered across a sea of rock and sand. To stay in one place, to build something permanent, they needed a miracle, and they found it not by looking out at the barren horizon, but by looking down. They began to notice the subtle clues the land itself provided. After rare rains, they might see patches of green flourishing at the base of a mountain range, far from any visible stream. They learned that water, once fallen as rain or snow in the highlands, did not simply disappear. It seeped deep into the earth, traveling silently through layers of gravel and porous rock, trapped beneath a ceiling of hard, impermeable stone. This hidden reservoir was the answer. It was a treasure vault protected from the evaporating heat and the shifting sands above. The great insight was realizing this groundwater could be intercepted, guided, and brought to the surface on their own terms. This was the genesis of a new kind of architecture, one that turned the earth itself into a pipeline. The initial attempts were likely humble, born of necessity. A family or small village might dig a simple, sloping trench into a hillside to reach the damp soil and collect seepage in a clay-lined basin. But from these small beginnings, a revolutionary idea took shape. What if you could dig a tunnel that started far downstream, in the dry plains where you needed water, and gently slope it backward, deep into the foothills, until it pierced that hidden aquifer? The water would then flow freely downhill through the tunnel and emerge exactly where you wanted it, all by the silent, relentless pull of gravity. This was the core principle. It was an act of incredible foresight, requiring planners to visualize the invisible contours of the land and the water table beneath it. They weren't just digging a hole, they were drafting a blueprint for the future, with only the stars and the slope of the land as their guides. This shift from relying on capricious surface water to engineering a reliable, subterranean supply was nothing short of a hydraulic revolution. It transformed the relationship between people and a hostile environment. No longer were they passive victims of the climate, they had become its architects. The decision to invest generations of labor into these hidden channels was a declaration of permanence. It said, "We are not leaving. We will make the desert bloom." And with that commitment, the stage was set for one of the ancient world's most silent and spectacular construction projects. The question was no longer if it could be done, but how. How do you build a river in the dark? The elegance of their solution was matched only by its simplicity, a design so perfect it earned a name that would echo across continents, the Qanat. This Persian word describes more than just a tunnel. It is the blueprint for an entire hidden river system. Picture a gently sloping underground channel, often no wider than a person's shoulders, that begins its life deep within an aquifer at the base of a mountain. From that starting point, it travels for miles, sometimes tens of miles, descending with a slope so slight you would barely notice it, all the while carrying water silently toward the plains below using nothing but the unyielding force of gravity. The genius of the Qanat lies in its invisibility. While Roman aqueducts were monumental statements of power, soaring across valleys on towering arches for all to see, the Qanat is a secret. Its presence on the surface is betrayed only by a line of circular openings, like a string of beads laid across the desert floor. These are the vertical access shafts, each one a doorway to the dark world below. The construction process itself was a masterpiece of phased engineering. It began not at the destination, but at the water source. Teams of specialists, known as Muqannis, would first locate the aquifer and dig the mother well. This was the deepest shaft, plunging straight down until it struck the life-giving water table, sometimes reaching depths of over 100 meters. Once this vital connection was made, the real work began. Starting from the planned outlet point, far out in the dry lands where the water was needed, the diggers would begin carving the main tunnel backward toward the mother well. They worked in near-total darkness, guided by oil lamps and an intimate knowledge of the rock, ensuring the tunnel maintained that critical, gentle downhill slope. As they inched forward, teams above them would sink the vertical shafts at regular intervals, every 20 to 50 meters. These shafts served a trio of crucial purposes. They provided essential ventilation for the workers below. They offered a way to lift out the immense amounts of excavated earth and rock, and once the system was complete, they became permanent access points for maintenance and cleaning. The entire structure was a triumph of passive design. By burying the water channel, the builders shielded it from the relentless desert sun, eliminating catastrophic evaporation. The earth itself acted as a natural filter, keeping the water cool and clean, safe from the dust and contamination of the surface world. And because it relied solely on gravity, it demanded no pumps, no fuel, and no complex machinery, just the initial, monumental human effort. A single Qanat was a sustainable masterpiece that could flow reliably for centuries, a silent, self-sustaining gift from one generation to the next. But to create such a network required more than just engineering skill. It demanded a new kind of social contract, a shared belief in a future worth digging for. But to transform this ingenious concept into the backbone of an empire required a vision as vast as the desert itself. That vision belonged to the Achaemenid Persians. Under the rule of legendary figures like Cyrus the Great and Darius I, the Qanat ceased to be a local survival tool and became a grand instrument of statecraft. Here was an empire that stretched from the banks of the Indus River to the shores of the Nile, encompassing a dizzying array of landscapes and peoples. Holding such a domain together demanded more than just armies and roads. It required a reason for disparate provinces to remain loyal, a tangible benefit to being part of the Persian world. The Achaemenids found that reason flowing silently beneath the earth. They realized that in an arid realm, the ultimate form of control was not just over land, but over the very source of life, water. So they systematized it. The Persian court didn't merely permit the digging of qanats, they actively commissioned them. They deployed teams of skilled engineers and laborers, the Muqannis, as imperial agents into the driest provinces. This was a deliberate hydraulic policy, a massive public works program designed to make the desert not just habitable but prosperous. The results were transformative. In regions once considered worthless frontiers, lush new settlements sprang up around the steady flow of these underground rivers. The empire could now plant fortified cities and agricultural estates in strategic locations that were previously impossible, securing its borders not just with walls but with orchards and wheat fields. This engineering prowess reached its most symbolic expression in the royal gardens, the Paradisa. These were not simple pleasure gardens, they were microcosms of the empire's power over nature, walled enclosures of stunning beauty and order built in the midst of the harsh Iranian plateau. They were filled with shade trees, fragrant flowers, and flowing channels, all fed by qanats. The word paradisa, meaning a walled enclosure, eventually passed into Greek as paradisos and into our language as paradise. Think about that for a moment. The ancient concept of an earthly paradise, a perfect, abundant garden, was literally made possible by this hidden water technology. The Qanat became a quiet, powerful thread weaving the empire together. A distant province might chafe under imperial taxes or governance, but its survival, its very ability to feed its people, was now tied to a system maintained and protected by the central authority. It created a shared dependency, a silent covenant between the ruler and the ruled. This demonstrates a profound historical truth that the most enduring foundations of power are often not palaces or monuments, but the humble, vital infrastructure that sustains daily life. The Achaemenids showed that to build an empire, you must first build a river and then you must bury it. Their legacy was a landscape forever altered, not by conquest alone, but by the gift of water drawn from the deep, dark heart of the earth. And as their influence spread, so too did the knowledge of this transformative technology, traveling along the very trade routes their empire protected. It was a secret too valuable to keep contained, and soon another ambitious civilization would look upon this idea and see the future of its own arid frontiers. The principles of buried rivers did not remain a Persian secret for long. As trade routes stretched and empires brushed against one another, the knowledge of how to coax water from stone began a slow migration westward. It would eventually reach the hands of history's other great master builders, the Romans. Famous for their soaring, arched aqueducts, the Romans are rarely first associated with hidden waterways. Yet in the sun-blasted provinces of North Africa and the Middle East, where surface water was a fleeting mirage, they too turned to the earth, crafting their own version of the subterranean conduit. Their systems shared the same brilliant core principle, harnessing gravity to guide water from distant aquifers, but the execution bore the unmistakable stamp of Roman order and ambition. Where a Qanat tunnel might follow the natural contours of the rock, a Roman subterranean channel was often a feat of geometric precision. Engineers lined the walls and floor with fitted stone or waterproof cement, creating a smooth, efficient pipeline that minimized leakage and friction. They incorporated regular, rectangular inspection chambers, allowing for maintenance crews to walk through sections of the tunnel, a level of access that reflected a military obsession with upkeep and control. This infrastructure was the lifeblood of Rome's farthest reaches. It supplied the relentless thirst of a legionary fortress on the edge of the Sahara, ensuring a garrison could hold its ground against both enemy forces and the desert itself. It fed the sprawling public baths, fountains, and private villas of resurrected cities like Carthage, allowing Roman urban life, with all its grandeur and complexity, to flourish on an alien continent. And perhaps most critically, it enabled the vast agricultural estates, the latifundia, that turned North Africa into the empire's breadbasket, shipping grain by the shipload to feed the restless populace of Rome. Here lies a fascinating contrast in philosophy. The Qanat often emerged as a communal endeavor, a project sustained by the shared labor and water rights of an entire village, its benefits distributed according to ancient, negotiated custom. Roman hydraulics, however, frequently bore the mark of a centralized state. They were projects commissioned by emperors, designed by army engineers, and built by legionaries or organized labor corps. Water was not just a resource, it was a tool of administration, a means to secure territory, reward loyalty, and display the beneficent power of Rome to its subjects. This reveals two distinct paths to solving the same existential riddle. One culture built from the ground up, weaving water rights into the fabric of local society. The other built from the state down, imposing hydraulic order as an extension of imperial will. Both were breathtakingly effective, proving that the fight for survival in the desert could inspire not just engineering genius, but profoundly different visions of community and control. Yet for all their stone-lined perfection, even the Romans could not defend their channels against every threat. The greatest danger to these hidden rivers was not an invading army, but something far more patient and insidious, a force that worked in silence year after year, slowly choking the life from the very systems that defied the desert. The true mastery of these ancient engineers was measured in fractions of a degree. In a world without laser levels or GPS, their most critical task was defeating distance with perfect, patient geometry. The life of the entire system, its ability to function for centuries, hung on a single, delicate principle: the slope. From the mother well to the final outlet, the tunnel had to descend at a gradient so slight it was almost imperceptible, often less than 1 degree over many miles. This was the golden rule, a non-negotiable line drawn by physics itself. A slope that was too steep would turn the gentle flow into a destructive torrent, scouring the tunnel walls, carrying away precious soil, and leading to catastrophic collapse. But a slope that was too shallow, even by a tiny margin, would allow the water to lose its momentum, to pool and stagnate, becoming a breeding ground for silt and sickness. The goal was a steady, walking pace for the water, a silent and sustainable journey. To achieve this over vast, uneven terrain required tools of elegant simplicity. Surveyors, likely working in teams, used long sighting poles and primitive but brilliant water levels. A water level is nothing more than a length of hose filled with water, but in the hands of a skilled artisan, it becomes a perfect horizontal reference. By marking points of equal height across the landscape, they could map out a path that lost elevation at just the right, consistent rate. It was a process of immense patience, of trial and correction, of trusting the unwavering truth of gravity over the deceptive eyes of the desert. They were not just digging a ditch, they were drafting a perfect, invisible line across the map of the underworld. This precise gradient was the system's greatest safeguard. Because the water moved slowly, without violent force, the tunnel did not need heavy reinforcement. The walls could be simply cut from the native rock or lined with brick, and they would hold for generations. The gentle flow also allowed silt and debris to settle naturally in designated basins, where they could be easily removed during regular maintenance through the access shafts. Every aspect of the design served this principle of calm, controlled motion. It was a testament to a profound understanding that in the struggle against a harsh environment, brute force often fails. The real victory came from persuasion, from working with the fundamental laws of nature rather than against them. By mastering the slow dance of gravity, they built rivers that did not roar but whispered, and in that whisper was the sound of empires growing. Yet this whisper was fragile, vulnerable to a threat that accumulated not in a sudden disaster, but in the quiet, relentless passage of time itself. The perfection of their geometry was carved out of darkness, one basket of earth at a time. While we marvel at the elegant slopes and enduring stone, we must remember that these hidden rivers were first shaped by human hands, in conditions few of us could comprehend. The true architects were the Muqannis, the master diggers whose very name became synonymous with this life-giving craft. Theirs was a world of profound shadows and immense pressure, both physical and psychological. Each day began with a descent into a vertical shaft, a narrow cylinder of light shrinking above them as they climbed down a simple rope ladder, often with nothing more than a flickering oil lamp for illumination. The air grew thick and still, heavy with the scent of damp earth. At the tunnel face, the space was typically so confined that a single worker could barely kneel or crouch, swinging a short-handled pick in a rhythmic, exhausting dance against the unyielding rock. Another would follow, scooping the debris into leather baskets, which were then hauled up the long chain of shafts by teams above, a human conveyor belt moving mountains of earth to the surface. The dangers were as constant as the darkness. A misjudged strike could puncture a hidden pocket of water, causing a sudden, violent flood in the confined space. The most feared risk was collapse, where a section of ceiling, weakened by an unseen fissure, would give way without warning. Poor ventilation could lead to a silent, invisible threat, as bad air, lacking life-giving oxygen, could overcome a worker before he even knew he was in distress. This was not a task for the forced labor of conquest, but a highly specialized profession, often passed from father to son. The knowledge required was immense and precious, a living library held in memory. A master Muqannis knew how to read the strata of the rock like a map, understanding which layers were stable and which promised danger. He knew the secret recipes for mortar that could withstand constant moisture, and the precise techniques for shoring up a fragile ceiling with timber braces or arched brickwork. These men formed tight-knit guilds, guardians of oral traditions that were as vital to the community's survival as the water they sought. Building a qanat was therefore more than an engineering project. It was a profound social covenant. Every family in a village might contribute labor or resources, understanding that the reward, a share of the life-giving water, was a direct result of their collective sacrifice. It was an investment in a future they themselves might not live to see, paid for in sweat, skill, and an unwavering courage that flowed as silently as the water they eventually set free. Their legacy is written not in grand inscriptions, but in the continued murmur of water in places where none should rightfully exist. And as these networks grew, they gave rise to something equally remarkable, not just a source of water, but an entire legal and social ecosystem built around its fair distribution. This mastery over water did more than just sustain villages, it built wonders. In the heart of the most arid landscapes, entire cities of stone and ambition rose from the sand, not in spite of the desert, but because of their command over its hidden veins. These were oasis cities, and their splendor was a direct product of hydraulic genius. Take the legendary city of Petra, carved into the rose-red cliffs of southern Jordan. The Nabateans were not merely lucky to find a canyon with a spring, they were architects of a water empire. In a land where rain was a rare and violent event, they engineered the entire landscape to capture and control it. They constructed massive dams to divert flash floods, carved intricate networks of channels and tunnels to guide water through the city's very heart, and chiseled vast cisterns into the bedrock to store enough for thousands. Every carved facade, every grand temple was made possible by this invisible, meticulously managed river. Petra's wealth flowed not from a visible oasis, but from a manufactured one, allowing it to become the ultimate crossroads for the incense trade, a hub where caravans could find guaranteed water and safety in a sea of rock. Similarly, the magnificent ruins of Palmyra stand in the Syrian desert as a testament to the power of planned abundance. Here, in a place that should have been a barren stretch between empires, a sophisticated web of springs, wells, and likely underground channels created a fertile island. This engineered oasis allowed Palmyra to become a sovereign power, a wealthy broker on the Silk Road where Roman and Persian influences met. Its grand colonnaded streets, its towering temples, and its luxurious tombs were all watered by a system that turned scarcity into spectacular surplus. These cities reveal a profound truth that in the ancient world, cultural and economic greatness was often a function of hydrological skill. They were not just built near water, they were built because their people had learned to converse with the desert, to negotiate for every single drop and direct it with precision. This made them magnets, beacons of stability and wealth in an unstable world. Their cosmopolitan crowds, their libraries and markets were all born from the quiet, constant flow of water through stone. Yet the very ingenuity that built these desert metropolises also created a new kind of challenge, one not of engineering but of law. For when a single, life-giving channel serves an entire community, who owns the water? And how do you ensure that this most precious resource, drawn from the collective labor of generations, is shared not by force but by fairness? Water rights became as vital as the water itself. With a single underground channel feeding an entire community, the question of fairness was not philosophical, it was the bedrock of survival. This led to the creation of some of history's most intricate and equitable water distribution systems. The flow from the Qanat's mouth was rarely left to chance or brute force. Instead, it was meticulously divided, often using a simple yet brilliant device known as a water clock or fenjon. This was not a clock that told the hour of the day, but the hour of the water. Imagine a calibrated bowl with a small hole in its bottom, placed in a larger basin of water. As the bowl slowly filled and sank, it marked precise, agreed-upon intervals of time. A farmer's share of the community's water was not measured in gallons, but in minutes, in the right to divert the entire flow into his field channels for a specific portion of the day or night. This system transformed a liquid resource into a reliable, scheduled commodity. Overseeing this delicate balance were community councils of elders or trusted water masters. They maintained the rotation schedules, settled disputes, and organized the essential, ongoing maintenance of the tunnels, ensuring that the shared source of life remained clean and open for all. This was a social contract written in water, a democratic practice born from absolute necessity. It meant that the wealth of the underground river did not flow only to the powerful, but could be parceled out with justice, ensuring that even the smallest landholder received his fair share of the desert's hidden gift. This equitable framework unlocked the Qanat's ultimate purpose, to perform a quiet miracle of transformation right on the surface. The true power of this hidden infrastructure was measured not in stone but in soil. By delivering a steady, predictable flow of water to the sun-baked plains, the Qanat performed a kind of alchemy. It turned the desert's margins into sudden, unexpected gardens. Regions that for millennia had supported only the sparse, wandering life of nomadic herders could now sustain permanent, settled agriculture. With this reliable source, farmers could cultivate thirsty crops like wheat and barley, the very staples of civilization. They could plant orchards of dates, pomegranates, and pistachios, whose deep roots thrived on the consistent moisture. This was an agricultural revolution conducted in whispers, one silent tunnel at a time. The result was a profound shift in human patterns. No longer bound to the uncertainty of seasonal rains or distant pastures, communities could put down permanent roots. They could build not just homes but granaries. The fields, now reliably watered, produced more than just subsistence. They produced a surplus. This surplus is the fundamental catalyst that changes everything. When a society produces more food than it immediately needs, it frees people from the daily grind of farming. Individuals can now specialize. Some become artisans, crafting tools, pottery, and textiles. Others become merchants, teachers, soldiers, or administrators. This division of labor is the essential foundation for complex culture, for trade, for art, for government. The Qanat, therefore, did more than just irrigate crops. It irrigated the very possibility of civilization in places the great river valleys had never reached. It allowed empires to plant their flags and their farms in the most unlikely soils, creating stable, productive provinces far from the Nile or the Tigris and Euphrates. The food from these engineered oases could feed distant cities, support standing armies, and fill the coffers of trade. The silent water beneath the sand was, in effect, the quiet economic engine of empires, proving that true power could spring from the deepest, darkest, and most carefully shared of sources. Yet, for all their resilience, these hidden rivers were not invincible. Their greatest threat emerged not from a failure of engineering or law, but from a slow, creeping change in the very world they had so brilliantly conquered. The silent water that fed empires also greased the wheels of global exchange, while the Qanat's gift of agriculture allowed societies to root themselves in place. Its other, equally vital role was in enabling movement on a staggering scale. Across the vast, searing expanses of Central Asia and the Middle East, the legendary Silk Road was not a single highway, but a fragile web of trails connecting the markets of China to the bazaars of the Mediterranean. For the merchants, pilgrims, and diplomats who dared this journey, the greatest adversary was not bandits or political borders, but simple, profound thirst. A camel caravan could carry silks and spices for weeks, but it could not carry enough water to cross a true desert. Survival depended on knowing where the next drink would be found. This is where the hidden rivers of the earth became the secret lifelines of history. The oases that dotted these trade routes were not accidental miracles of nature. Many were carefully engineered way stations, their lush palms and clear pools sustained by the reliable flow of a qanat or a deep, expertly dug well. At these precious points, grand caravanserais were built, fortified complexes offering shelter, security, and most importantly, water. Here, exhausted travelers could rest, animals could be watered and fed, and goods could be traded even before reaching their final destination. The caravanserai was more than an inn. It was a nerve center of cross-continental commerce, and its beating heart was the water channel that kept it alive. Without these engineered oases, the Silk Road would have been a death sentence, a series of impassable dry gaps severing the connection between worlds. The Qanat, therefore, performed a dual miracle. It created the agricultural surplus that produced trade goods, and then it created the hydrated stepping stones that allowed those goods to travel. It carried not just water, but the very possibility of contact. Alongside bolts of silk and sacks of pepper, these watering stops facilitated the flow of something even more precious: ideas. Buddhist monks, Islamic scholars, Christian missionaries, and philosophers of all traditions met in the shade of these oasis towns, their debates and dialogues watered by the same underground streams. Technologies like paper-making and gunpowder, astronomical knowledge, and artistic styles all hitched a ride with the caravans, their journey made possible by a drink of water drawn from the deep earth. So when we picture the Silk Road, we should not see only camels and deserts. We must also see the invisible architecture beneath the sand, the quiet, constant flow that made every conversation, every transaction, every shared discovery possible. This hidden infrastructure was the silent partner to every merchant and explorer, the true enabler of the first globalized world. Yet this vast and ancient network, so crucial to the rise of civilizations, would eventually face a challenge from within, a shift in priorities that would leave the whispering tunnels to fall silent. The distribution of water demanded a distribution of trust. A single underground river could sustain an entire village, but without clear, inviolable rules, that same river could become a source of bitter conflict. To prevent this, the societies that built these hidden channels also had to build something equally intricate: a legal and social framework to govern every drop. This was not a luxury, it was a matter of survival, giving rise to some of history's most fascinating and equitable systems of resource management. In Persia, the responsibility often fell to a respected local council or a specially appointed official known as the Qanat, the keeper of the water. This individual was not a warrior or a king, but a judge, an engineer, and a community elder rolled into one. His authority was absolute when it came to the flow, because his decisions determined whether a family would eat or go hungry. The core principle was fairness, achieved through a brilliant method of division. Instead of trying to split the physical water, which was messy and imprecise, they divided time itself. A farmer's share was not a volume, but a scheduled window, a right to divert the entire flow of the Qanat into his own irrigation channels for a specific period. This period might be a few hours during the day or a turn in the middle of the night, a rhythm of life set by the water's clock. To measure these intervals with precision, they used ingenious tools. In the daylight, a sundial carved into a central stone could mark the passage of a water share. For turns after dark or on cloudy days, they relied on the water clock, the fenjon. This was a calibrated copper bowl with a tiny hole in its bottom. Placed in a basin of water, it would fill and sink at a constant rate. The moment it disappeared beneath the surface marked the end of one farmer's turn and the beginning of the next, a system so reliable and transparent that disputes were rare. This framework created a powerful web of mutual dependence. Every user upstream and downstream was linked in a chain of collective responsibility. If one farmer neglected to clear silt from his section of the main channel, or if a landowner let an access shaft collapse, the entire system could falter, jeopardizing the water for everyone below. This meant that maintenance was not a voluntary chore, but a legally enforced duty. The community would organize regular cleaning expeditions, descending into the tunnels to remove debris and repair walls, understanding that their individual survival was inextricably tied to the health of their shared lifeline. What emerged from this necessity was a remarkable social fabric, woven from cooperation rather than competition. The law of the Qanat taught that the greatest resource was not the water alone, but the trust required to share it justly. It showed how an environmental challenge could forge institutions of remarkable resilience and fairness, systems where the powerful could not simply take what they wanted, because the community's survival depended on balance. These quiet codes of conduct, written in water and time, may be the most enduring legacy of all, proving that the true test of a civilization is not just how it conquers a desert, but how it learns to share the spoils of that victory. The water's journey did not end at the field's edge. Once drawn from the deep earth and divided by law, it flowed into the heart of the city itself, becoming the lifeblood of architecture and artistry. This was where utility transcended survival, where the precious liquid was transformed into an expression of culture, power, and profound comfort. In the grand palaces of Persian shahs and the public squares of Roman provincial capitals, water was choreographed. It danced in ornate fountains, not as a wasteful display, but as a public declaration of abundance and control. It rested in broad, shallow reflecting pools, mirroring the sky and the surrounding arches, creating an oasis of calm that offered psychological relief from the relentless desert sun. The sight and sound of moving water in such a parched landscape was a sensory luxury, a constant reminder that human ingenuity had tamed the elements. But the integration went far deeper than aesthetics, literally. Consider the Persian wind tower or bajir. This is a tall, chimney-like structure capped to catch the slightest breeze from any direction. The genius is in what happens next. That captured wind is funneled down the tower and directed over a small indoor pool of water, often fed by a qanat channel running beneath the building. As the air passes over the cool water, it drops in temperature, becoming a refreshing draft that circulates through the living spaces. This was natural air conditioning, engineered centuries before electricity, a silent system that turned thick stone buildings into cool sanctuaries against the summer heat. Similarly, vast underground cisterns, meticulously plastered to prevent leakage, acted as the community's savings account. They stored surplus water from the rainy seasons or from periods of strong flow, holding it in reserve for times of drought or siege. This was strategic planning on a grand scale, an acknowledgement that even the most reliable hidden river could face challenges. Every element worked in concert. The qanat provided the constant, clean supply, the cisterns ensured stability, the wind towers and pools delivered comfort, and the fountains celebrated the achievement. This represents a holistic philosophy now often lost. Water management was not a separate, utilitarian chore. It was an integral part of architectural design, urban planning, and daily well-being. It blended seamlessly into the fabric of life, from the humble home cooled by a badger to the majestic palace adorned with water gardens. This integration shows a society that did not just conquer its environment through brute force, but learned to collaborate with it, to harness its physics for pleasure and respite. The desert empire could thus offer its citizens something priceless, not just survival, but a quality of life marked by serenity and cool repose, a true haven carved from the heart of the arid world. Yet this delicate, interconnected system of water, architecture, and society was built on a fragile balance, one that could be disrupted by forces both natural and human. The quiet perfection of these hidden rivers presents a riddle that spans continents. From the deserts of Persia to the mountains of Peru, strikingly similar systems of underground water channels appear in cultures that, according to our maps, should never have met. This is one of hydrology's great mysteries, a question of origins that divides historians. Did this brilliant idea have a single birthplace, a moment of genius that then traveled the ancient world along silent trade routes? Or was it born separately, time and again, wherever people faced the same desperate arithmetic of too much sun and too little rain? The evidence for a single origin is compelling. The earliest and most extensive use is undeniably in ancient Persia, with sophisticated qanats appearing over 2,500 years ago. As the Achaemenid Empire expanded, its engineers would have carried this vital technology to new provinces. Later, the conquests of Alexander the Great and the vast trade networks of the Silk Road could have served as a bridge, transmitting the concept westward to the Romans in North Africa and eastward to the arid regions of Afghanistan and the Turpan Basin in China. It is a clean, logical story of cultural diffusion, where knowledge flows like water itself from a single, powerful source. Yet, there are fascinating outliers that challenge this neat narrative. In the Arabian Peninsula, particularly in Oman, ancient systems called aflaj bear a remarkable resemblance to qanats, with gently sloping tunnels and vertical access shafts. Their origins are deeply ancient, possibly predating significant Persian influence in the region. Even more startling are the Puquios of Peru. In the Nazca Desert, a landscape as dry as any on Earth, a pre-Columbian civilization built spiral stone openings leading to subterranean aqueducts that tapped groundwater, sustaining their famous culture and its mysterious geoglyphs. The distances here are staggering, with an ocean and hemispheres separating these builders from the Middle East. So, are we looking at a case of astonishing coincidence or evidence of a lost chapter of global connection? The answer may lie not in maps, but in the human mind facing a wall of absolute necessity. This phenomenon is known as convergent evolution. In nature, unrelated species often develop similar traits, like the wings of bats and birds, because they are solving the same environmental problem. Technology can evolve the same way. When the problem is absolute, when the survival of your community depends on finding a hidden, sustainable water source, the logical solutions are surprisingly few. You must go underground to avoid evaporation. You must use gravity to move the water because pumps do not exist, and you must have access shafts for construction and maintenance. The design, in other words, is almost dictated by the physics of the problem itself. A brilliant engineer in Persia and a brilliant engineer in Peru, staring at the same type of desert, could very well arrive at the same elegant answer, not because they shared a blueprint, but because they shared a desperation. This mystery forces us to reconsider how innovation spreads. It suggests that some ideas are so perfectly suited to a universal human need that they can be both transmitted and independently discovered. The silent tunnels beneath the sand may be evidence of a shared human genius, a testament to our species' relentless drive to solve the same fundamental puzzle, whether we are connected by caravans or separated by entire worlds. The true story is likely a blend, a tapestry woven from both communication and coincidence. But this only deepens the wonder because it means this technology represents something more profound than a mere invention. It is a recurring answer to one of humanity's oldest questions. And as we will see, even the most perfect answer can be forgotten, its whispers slowly silenced by the very sands it once conquered. The mystery of parallel invention finds its most dramatic echo on the other side of the world. In the hyper-arid coastal desert of southern Peru, where rain is measured in decades rather than years, the Nazca culture left behind more than just the vast, enigmatic lines etched into the earth. To sustain the civilization that created those sprawling geoglyphs, they engineered a hidden water network of breathtaking cleverness, the Puquios. These are not the long, linear tunnels of Persia, but a system uniquely adapted to its own brutal landscape. From the surface, a Puquio appears as a spiraling, funnel-shaped entrance carved directly into the dry ground, resembling a giant stone snail shell leading down into the darkness. These spirals were not merely decorative, they were functional masterstrokes. The design served as a windbreak, preventing blowing sand from clogging the shaft, while also creating a cool, shaded microclimate for the workers who maintained it. The shaft plunged downward, sometimes over 15 meters, until it intersected with a subterranean aquifer. From this mother well, horizontal galleries, often lined with stones, radiated outward to tap the water table, feeding it into a network of surface canals that distributed the life-giving resource across the desert floor. This was the lifeblood of Nazca society. The Puquio system transformed barren valleys into cultivated plots where they could grow cotton, maize, and beans, and sustain the population needed to conceive and execute their monumental desert art. The very existence of the Nazca lines, those massive figures visible only from the sky, depends on this hidden hydrology. A society cannot plan celestial patterns if it is desperately searching for its next drink. The dating of the Puquios remains a topic of scholarly discussion, with some estimates placing their construction around 2,000 years ago. This chronological mystery only deepens the intrigue, as it places their development in a time frame roughly contemporary with the great Qanat systems of Persia, yet with an ocean and hemisphere between them. There is no evidence of cultural contact, no shared blueprint carried across the seas. This forces a profound realization. When the environmental challenge is absolute, when the desert offers no quarter, the spectrum of possible solutions narrows dramatically. Separate cultures with no knowledge of each other arrived at the same core principle: go deep, find the hidden water, and guide it to the surface using gravity. The Puquios and the Qanats are a stunning example of convergent technological evolution. They prove that necessity is not just the mother of invention, but that she speaks a universal language. In the face of existential thirst, the human mind, whether in the mountains of Iran or the plains of Peru, can independently discover the same elegant answer written in water and stone. It is a testament to a shared ingenuity that transcends geography, a silent conversation between civilizations who never met, yet who whispered the same secret into the earth. Yet for all their resilience, these hidden rivers were not eternal. The same societies that had invested generations in their creation could, over time, find themselves unable to sustain them. The decline of a Qanat network was rarely a sudden collapse, but a slow, quiet fading, a process measured in decades of accumulating silence. Political upheaval was often the first crack in the foundation. When central authority crumbled during invasions or civil conflict, the organized, collective effort required for maintenance became impossible. The guilds of Muqannis might be dispersed, their knowledge not written down in manuals but carried in memory and practice. If that chain of mentorship was broken, the understanding of how to diagnose a tunnel's illness or repair a collapsed gallery could vanish within a generation. Furthermore, the economic landscape could shift beneath the desert itself. If major trade routes like the Silk Road, changed course due to new political realities or the rise of sea travel, the bustling oasis cities they supported would wither. The caravans stopped coming, the markets grew quiet, and the population that once maintained the water channels would dwindle or move away. Without a community to share the labor, the annual cleaning of silt from miles of tunnel became an insurmountable task for the few who remained. Perhaps the most insidious threat came from the resource itself. In some regions, as populations grew and more land was brought under cultivation, the demand on the hidden aquifer became too great. Water was drawn out faster than nature could replenish it. Slowly, inexorably, the water table would retreat deeper into the earth. The mother well, once a reliable fountain, would run dry. To reach the vanishing water, the entire tunnel would need to be dug deeper, a monumental undertaking requiring resources and expertise that a struggling community simply no longer possessed. The end was not dramatic but profoundly sad. One season, the flow from the outlet would be a little weaker. The next, it might stop for a week, then resume as a trickle. Finally, it would cease altogether. The silence above ground was absolute. Without water, the fields turned to dust, the orchards withered. Families who had lived on that land for centuries packed what they could carry and left, joining the flow of history as refugees from a paradise they themselves had built. The abandoned village, with its empty homes and dry irrigation ditches, became a monument to a forgotten covenant with the earth. It stands as a humbling lesson that our greatest creations are sustained not just by stone and slope, but by continuity, by shared purpose, and by a delicate balance with the very nature we strive to command. The desert, patient and timeless, would simply wait and begin to reclaim its own. For centuries, the whispers of these buried rivers fell silent, remembered only in local legends and the crumbling outlines of long-abandoned fields. Their rediscovery began not with a single dramatic excavation, but with the puzzled observations of 19th-century European travelers and military surveyors. Riding across what they assumed were barren, empty lands, these outsiders would come across strange, inexplicable lines of circular depressions marching across the desert floor like the footprints of a giant. Local guides might call them qanats or carrés, speaking of old water channels, but to the Western eye, accustomed to Roman aqueducts leaping across valleys, these holes in the ground seemed primitive, almost accidental. It was only when adventurous souls dared to descend into one of those dark shafts that the scale of the achievement dawned on them. They found themselves not in a simple well, but at the top of a breathtakingly deep vertical chimney, looking down a line of perfect, repeating circles of light that vanished into a profound darkness, the spine of a hidden river. Early archaeologists, armed with little more than notebooks, ropes, and lanterns, began the painstaking work of documentation. They mapped the surface alignments, measured depths, and interviewed the last generation of aging Muqannis, the keepers of a fading oral tradition. Their published accounts were filled with a sense of awe, reframing these features from curious holes into monuments of a lost hydrological science. Today, that exploration has entered a new, silent revolution. Modern archaeologists no longer need to physically crawl through every unstable tunnel to understand its secrets. They deploy technologies that see through the earth itself. Ground-penetrating radar sends pulses down from the surface, painting a ghostly image of buried voids and channels on a computer screen. Drone-mounted lasers scan the terrain to create hyper-detailed three-dimensional maps, revealing the subtle surface signatures of entire networks that are invisible to the human eye walking on the ground. Satellite imagery, analyzing minute differences in vegetation health, can trace the path of ancient water flows long after the last drop has vanished. This technological toolkit allows researchers to understand the system as a whole. They can trace a qanat from its mother well to its final outlet, calculating its precise gradient and total engineering effort. By analyzing sediment cores pulled from silted-up tunnels, They can read a history of climate written in layers of dust and mineral deposits, understanding periods of drought and abundance that affected the civilization above. Each laser scan, each radar profile, is quietly resurrecting the blueprint of a civilization's survival manual, but the true story is still in the soil and stone. When archaeologists carefully excavate an access shaft or a section of collapsed tunnel, they are reading a diary of labor. They find the tool marks of bronze and iron picks on the tunnel walls, each strike a testament to human endurance. They uncover the simple oil lamps that lit the endless dark, and the ceramic fragments left by a worker taking a meal break 2,000 years ago. They study the ingenious brick arches built to shore up a weak ceiling, a permanent solution crafted by a nameless engineer. This work does more than catalog an ancient machine. It recovers the human rhythm that made it beat. It gives voice to the generations of diggers, surveyors, and water judges whose collective will bend the desert to their purpose. In doing so, archaeology performs its most vital role. It transforms a forgotten engineering marvel into a poignant story of community, foresight, and a fragile covenant with an unforgiving world. The stones themselves are now beginning to speak, and what they tell us challenges our modern assumptions about sustainability and shared purpose. The stones of the past are not always silent. In the rugged highlands of Iran and the sun-baked valleys of Oman, the ancient rhythm of water still whispers from the earth. Astonishingly, after 2.5 millennia, tens of thousands of these qanat systems continue to flow, not as museum exhibits, but as the beating heart of daily life. They irrigate fields of saffron and pistachio trees, supply drinking water to remote villages, and fill the basins of historic public baths. This is not a story frozen in archaeology. It is a living tradition, a direct line to an ancient wisdom that has never been broken. In many communities, the role of the Muqannis, the master digger, is still passed down through families. These modern guardians maintain the tunnels using a pragmatic blend of old and new. They might descend the same hand-carved shafts as their ancestors, clearing silt with traditional tools, but they now also use concrete to reinforce a collapsing section or a small electric pump to assist a weakened flow. The social structures endure as well. Water shares are still meticulously calculated using updated versions of the old time-based systems, overseen by local water councils that settle disputes and organize the annual cleaning, a communal duty that reinforces social bonds as surely as it maintains the channel. This continuity offers a profound lesson. These qanats are sustainable in the truest sense of the word. They operate on pure gravity, demanding no fossil fuels, no electricity, and no complex chemical treatments. The water remains cool and clean, filtered through layers of earth. In an era of deepening water scarcity and energy crises, this ancient technology presents a powerful counterpoint. It challenges our assumption that newer and more complex is always better. A modern deep well, drilled with industrial rigs and powered by diesel pumps, can drain an aquifer in a generation, leaving behind salted earth and empty reservoirs. The qanat, by contrast, is a model of gentle extraction. Its very design prevents overuse, as it can only draw what the aquifer naturally provides. It teaches a philosophy of balance, of taking only what the earth willingly gives. These living waterways are more than infrastructure, they are cultural anchors. The annual maintenance festival, the shared responsibility, the sound of water in the courtyard, these are threads in a fabric of identity. They remind us that some solutions are timeless because they are born from a deep, patient conversation with the environment. They ask us a quiet, urgent question as we face our own planetary challenges. What have we forgotten about working with the world rather than simply demanding more from it? The enduring flow of a qanat carries a message far older than its stones. In a world now defined by climate uncertainty and deepening water stress, these ancient networks stand as a masterclass in principles we are struggling to relearn. Their sustainability was not an added feature, but the very core of their design. They operated on the most renewable energy source in the universe, gravity. No diesel pumps, no electrical grids, just the silent, constant pull that has moved planets since the beginning of time. This passive system meant they created no emissions, demanded no fuel shipments, and required no complex machinery that could break down. Their environmental footprint was astonishingly light. By traveling underground, they avoided the catastrophic evaporation that plagues open canals in desert heat, and their gentle, seep-based extraction from aquifers was inherently self-regulating. A qanat could only draw the water that the earth naturally provided, never draining the source faster than it could recharge. This is a stark contrast to many modern methods. Industrial deep wells, with their powerful pumps, can lower water tables dramatically in just a few years, leaving the land above to sink and salt to poison the soil. Massive reservoir projects, while engineering marvels, can displace communities, alter ecosystems, and lose tremendous volumes to the same sun the ancients learned to evade. The qanat achieved something modern engineering often overlooks: balance. It was not a conquest of the water cycle, but a collaboration with it. This ancient wisdom is now drawing the attention of a new generation of hydrologists and urban planners. In arid regions from the American Southwest to North Africa, researchers are studying these systems not as relics, but as blueprints. The principles of passive, gravity-fed distribution, decentralized local management, and aquifer recharge are inspiring modern designs for green infrastructure. The idea is to move away from brittle, centralized, energy-intensive water grids and toward resilient, community-scaled systems that work with the local landscape. Some projects are reviving and cleaning abandoned qanat networks to supplement municipal water supplies. Others are using the concept to design new subsurface irrigation that delivers water directly to plant roots, minimizing waste. The lesson here is not that we must abandon modern technology, but that we have forgotten a key ingredient in our calculations: humility. The qanat teaches that true sustainability is not a technological endpoint, but a philosophical starting point. It is the practice of working within ecological limits, of viewing water not as a commodity to be mined, but as a cycle to be joined. It is the understanding that a society's longevity is measured by its ability to take only what the earth can perpetually give. In their silent, patient flow, these buried rivers ask us a question we can no longer afford to ignore. What does it mean to build a civilization that does not exhaust its own foundations? Their profound mastery over water was achieved not with complex machinery, but with a toolkit of elegant simplicity. The true genius of these engineers lay in how they used humble, reliable instruments to solve problems of breathtaking scale. To carve a perfectly sloped river through miles of rock, they first needed to defeat distance with perfect geometry. Their most vital tool was a device for finding the true horizontal, the unshakable baseline from which all their calculations began. The Romans had the chorobates, a long wooden frame, perhaps 20 feet in length, with a carefully carved groove running along its top. This groove would be filled with water, and because water always seeks its own level, the surface of this liquid became a flawless reference line. By sighting along this water plane, surveyors could mark points of equal elevation across rolling hills and rocky outcrops, drafting an invisible contour map that would guide the tunnel's entire path. In Persia, similar principles were at work with simpler wooden frames or even just long, water-filled trenches. The goal was always the same: to establish a line that gravity itself would respect. Once the path was marked, the brutal work of excavation began. The primary tools were the iron-tipped pick and the shovel, extensions of human muscle and will. In the narrow, airless confines of the tunnel face, a worker would swing his short-handled pick in a rhythmic, exhausting arc, chipping away at the unyielding earth. Behind him, another laborer would fill leather baskets with the spoil. These baskets were then attached to ropes and hauled up the vertical access shafts by teams above, a human pulley system lifting tons of earth and stone to the surface, one heavy load at a time. Lighting this underworld was a constant challenge. Simple oil lamps fueled by olive oil or animal fat cast a flickering, smoky glow that pushed back the absolute darkness. These small flames were the only stars in that deep night, illuminating the sweat-streaked faces of the diggers and the rough texture of the tunnel walls. Precision was maintained through constant vigilance to ensure that two teams digging from separate shafts would meet perfectly in the middle. They relied on alignment techniques that seem almost magical in their straightforwardness. From the top of one shaft, a worker might lower a heavy plumb bob, a simple weight on a string, to establish a true vertical line. Using this as a guide, they could then sight across to the next shaft with a cord or a wooden pole, checking and rechecking their direction. It was a process of constant correction, of trusting simple physics over the deceptive senses. The final touch was making the channel endure. The lining of the tunnel was adapted to the local geology. In stable, compacted soil, the walls might simply be packed smooth with clay. But in loose, crumbly strata that threatened collapse, the builders would line the entire passage with fired bricks or fitted stones, creating a permanent, waterproof conduit. This was not just digging, it was underground masonry, a craft performed in the dark by feel and tradition. The entire toolkit, from the water level to the oil lamp, proves a timeless truth. Profound innovation is rarely about inventing something entirely new, but about mastering the perfect application of simple, reliable tools to a monumental problem. These builders understood their materials, they trusted the laws of nature, and they possessed the patience to let both do their work. With these quiet instruments, they drafted blueprints in the air and then carved them into the heart of the earth, one precise, painstaking strike at a time. This deep knowledge was not written in books, but in the landscape itself. Before a single stone was moved, the ancient engineers had to become fluent in the silent language of the desert, reading its climate and geology like a map to hidden treasure. Their success hinged on a profound, empirical understanding of their specific place on Earth, a science developed through generations of patient observation. First, they had to identify the right mountains. Not every range would do. They needed foothills that acted as natural water towers, peaks high enough to capture sufficient rainfall or seasonal snowmelt. This precipitation was the entire system's fuel, the source that would slowly seep down to recharge the deep aquifer. Choosing the wrong mountain meant digging a tunnel to nowhere. Then came the critical reading of the soil and rock. The composition of the earth determined life or death for the diggers below. Loose, sandy soil was a death trap, prone to sudden, catastrophic collapse. The ideal terrain was often found on the alluvial fans spreading from mountain bases, where millennia of sediment had been washed down and compacted into stable, granular layers. Here, the tunnels could hold their shape, and the porous gravel acted as a perfect natural filter, cleaning the water as it traveled. Perhaps their most subtle mastery was understanding the aquifer's pulse. The water table was not a static line, but a living thing that breathed with the seasons, rising after the rains and falling during the long dry spells. Sighting the mother well required knowing this rhythm intimately. It had to be dug to a depth that would strike water even at the lowest point of the annual cycle, ensuring a continuous flow year-round. Too shallow and the well would run dry for months, starving the entire network. Too deep, and it was an exhausting, unnecessary waste of precious labor. This was not guesswork. It was a data-driven craft built on centuries of trial and error, of noting which valleys stayed green longest, of observing the behavior of test pits, and of passing down hard-won lessons from elder to apprentice. They were, in every meaningful sense, expert climatologists and hydrologists long before those titles existed. Modern science, with its satellite surveys and geological core samples, now confirms the astonishing accuracy of their choices. We can see that the greatest Qanat networks align perfectly with subsurface fault lines that channel groundwater, or with specific sedimentary layers that act as ideal pipelines. Their silent, intuitive reading of the Earth has been validated by our loudest technologies. This reveals a fundamental truth about their achievement. They did not conquer their environment through brute force, but through deep, respectful dialogue with it. They listened to the desert's secrets, written in the flow of sand and the persistence of a single resilient plant, and they answered with a river of their own. The water that emerged from the darkness was never seen as a simple commodity. In the worldview of the ancient Persians who perfected the Qanat, this life-giving flow was a sacred trust. Zoroastrianism, the dominant faith of the Achaemenid Empire, held water as one of the 7 primordial creations of the divine, an element to be kept absolutely pure. A Qanat, therefore, was far more than a piece of infrastructure. It was a consecrated vessel, a channel for a holy gift. This spiritual framing shaped every aspect of its existence. The act of digging a new tunnel was often preceded by prayers and rituals, seeking blessing for the monumental task ahead. The moment the first water broke through at the outlet was cause for a community-wide celebration, a festival of gratitude that wove the new channel into the social and spiritual fabric of the village. This profound reverence extended to the water's journey above ground as well. The distribution points, where the channel split into smaller irrigation ditches, became more than just utilitarian junctions. They were natural gathering places, shaded spots where people would meet to talk, share news, and reinforce community bonds while collecting water for their homes. The sound of the flow, the coolness in the air, the very sight of abundance in the arid landscape, all served as daily reminders of a covenant not just among people, but between humanity, the divine, and the land itself. This spiritual dimension had a powerful practical consequence. It enforced a culture of stewardship. To pollute the Qanat was not merely a civic offense, it was a spiritual transgression. The strict social codes governing water use and maintenance were upheld not only by community law, but by a deeper sense of sacred duty. This intertwining of the practical and the transcendental reveals a fundamental truth about these societies. For them, survival and spirituality were not separate domains. The technology that ensured their physical existence also nourished their cultural and religious identity. The Qanat was a prayer made manifest in earth and water, a continuous, flowing testament to the idea that the greatest human achievements are those that serve both the body and the soul. It challenges our modern, often purely utilitarian, view of resources. It asks us what we lose when we see water only through the lens of economics and engineering, forgetting the awe, the gratitude, and the profound responsibility that its gift once commanded. To grasp the true brilliance of the buried river, we must place it beside the other great waterworks of antiquity. Across the ancient world, civilizations confronted the same fundamental need, but their answers were shaped by the land they called home. In the lush floodplains of Mesopotamia and Egypt, the solution was written on the surface. Vast networks of open canals diverted the seasonal floods of the Tigris, Euphrates, and Nile, spreading fertile silt and life across the fields. These were monumental achievements of organization, enabling the rise of the world's first cities. Yet, this surface-level strategy came with inherent vulnerabilities. In the blistering sun of the Near East, a significant portion of the precious water simply vanished into the air through evaporation. The same silt that nourished crops would gradually fill the canals, demanding constant, back-breaking labor for dredging. And because the water flowed in the open, it was easily contaminated by waste, animals, and debris, posing a constant threat to public health. Meanwhile, other cultures pursued control through brute force, building massive dams to impound rivers in reservoirs. The remains of the Marib Dam in Yemen, for instance, stand as a testament to this ambition. These structures could provide immense water security and irrigation potential, but they represented a single point of catastrophic failure. A structural breach or an overwhelming flood could wipe out the stored water and the communities downstream in an instant. Furthermore, such projects demanded absolute, centralized authority, vast armies of conscripted labor, and a rigid hierarchy to maintain. The dam was a symbol of a ruler's power over both nature and people. The Qanat emerged from a completely different philosophy. Its genius was not in dominating the landscape, but in collaborating with it, in finding a hidden path of least resistance. By burying the water channel, it solved the core weaknesses of surface systems at a stroke. Evaporation was virtually eliminated as the water traveled in the constant cool of the earth. Silt buildup was minimized because the gentle, gravity-fed flow lacked the erosive power of a rushing canal, and what little sediment accumulated could be cleaned from designated access points. Most importantly, the earth itself acted as a perfect natural filter, delivering cool, clean water that was protected from the contamination of the surface world. This was public health engineering on a geological scale. Its social structure was as resilient as its design. Unlike the top-down command needed for a massive dam, a Qanat network was typically managed from the ground up by the community it served. This decentralized model made it remarkably robust in the face of political collapse. If an imperial capital fell, the local water council could still meet, the Muqannis could still make repairs, and the water could keep flowing. The system was maintained not by imperial decree, but by the direct, vested interest of every user. This comparison reveals a crucial principle, that there is no single perfect solution, only the perfect solution for a specific context. The surface canals of Mesopotamia were ideal for flat, river-fed plains. The Qanat was the master key for deep, stable aquifers in mountainous deserts. It was a specialized, hyper-efficient adaptation, a lesson in working with extreme constraints to create enduring abundance. Where a grand canal or a towering dam might have been a spectacular failure, the silent, hidden Qanat became the quiet, unstoppable heartbeat of a civilization. This contextual intelligence may be their greatest gift to us, a reminder that sustainability is not a universal blueprint, but a careful, patient conversation with the particulars of a place. The silence of a collapsed shaft tells its own story. Scattered across the deserts of the world, from the plains of Syria to the remote basins of Xinjiang, lie the haunting remains of Qanat networks that have fallen silent. These are not ruins in the traditional sense with toppled columns or carved facades. They are negative spaces, a ghostly architecture revealed only by lines of sunken depressions and mounds of excavated earth slowly being reclaimed by the wind. To the modern researcher, these sites are not just empty, they are crime scenes of a sort, holding forensic evidence of a civilization's final struggle with its environment. Investigating them is a delicate science of reading dust and displacement. By meticulously mapping the pattern of collapsed access shafts, archaeologists can trace the tunnel's original path with precision. They measure the depth of each shaft, searching for clues. If the shafts grow shallower as they near the mother well, it suggests the builders were chasing a retreating water table, digging desperately to maintain contact with a vanishing source. This pattern points to a prolonged, devastating drought, a climatic shift that slowly starved the system over generations. Inside the tunnels themselves, the layers of silt are like pages in a geological diary. A sudden, thick deposit of coarse sand might indicate a catastrophic flash flood that breached the tunnel from above, filling it in a single, violent event. A finer, consistent layer of dust, however, tells a slower, sadder tale. It speaks of gradual neglect, of years passing without the communal cleaning rituals that kept the channel clear. This points toward a social, rather than environmental, collapse. Perhaps a conflict forced families to flee, or a wave of illness took the specialized knowledge of the Muqannis to their resting places. Without a community to share the labor, the annual maintenance became impossible, and the life-giving flow was choked from within. In some regions, the clues are more dramatic. A Qanat tunnel found severed by a clean, vertical fault line is a stark signature of an ancient earthquake. The ground itself shifted, cutting the channel off from its aquifer as cleanly as a surgeon's scalpel. In that instant, the engineering masterpiece became a dry hole in the ground. Each abandoned network, therefore, is a multifaceted time capsule. It does not record a single cause, but a complex interplay of forces. It might reveal a story of a community that weathered a drought, only to be dispersed by distant political turmoil. Or it might show a system perfectly maintained for centuries, until one day the earth moved and rewrote the map of the underworld. These silent sites teach a humbling lesson about the fragility of even our greatest adaptations. They show that a society's covenant with its environment is a living agreement, requiring not just brilliant initial construction, but perpetual vigilance, shared responsibility, and a measure of luck against the immense, unpredictable forces of the planet. The dust settling in these dry tunnels is the final sediment of a broken conversation, a reminder that all our gardens, however ingeniously watered, are rooted in a foundation of delicate and relentless care. The same aquifers that fed these ancient channels for centuries are now being drained in decades. A new kind of well has appeared across arid landscapes, one that does not whisper but roars with mechanical power. The deep tube well, driven by electric or diesel pumps, can plunge hundreds of meters into the earth, pulling water to the surface with a force and speed the old builders could never have conceived. In the short term, this seems like pure progress, a technological triumph over scarcity. A single modern well can irrigate vast fields, supply a growing city, and deliver abundance at the flick of a switch. But this power comes with a hidden, devastating cost, where a qanat gently sips from the aquifer following its natural rhythm. The industrial well gulps. It extracts water far faster than the slow cycles of rain and seepage can possibly replenish it. The result is a phenomenon hydrologists call groundwater mining, where we are not using a renewable resource but exhausting a finite one. As more and more of these powerful wells are drilled, the regional water table begins a steady, silent retreat, sinking deeper into the earth year after year. This creates a heartbreaking chain of events. A community may have a qanat that has flowed since the time of the Persian kings, sustaining orchards and families for generations. Then, a large agricultural operation or a new town installs a battery of deep wells a few miles away. The pumps run day and night. Slowly, imperceptibly at first, the flow from the ancient qanat weakens. The water becomes a trickle, then a damp spot, then nothing but dry stone. The mother well, which once tapped into a plentiful underground lake, now hangs in empty air. Its connection severed because the source it was designed to meet has fled deeper into the dark. This is the tragic paradox of our time. The very technology developed to solve water scarcity is actively destroying the most sustainable water systems humans ever invented. The qanat, a masterpiece of balance designed to last 1,000 years, can be rendered obsolete in a single generation by the unchecked pursuit of immediate abundance. It is a conflict between two philosophies of time. One is patient, engineered for perpetuity, accepting the limits of what the earth can give. The other is urgent, engineered for the present, operating on the assumption that more can always be found. The dust gathering in the abandoned tunnels is not just a sign of neglect, it is a direct consequence of our modern thirst. This silent crisis forces a difficult question upon us. How do we balance the undeniable needs of today with the wisdom of systems built for forever? The answer may not lie in abandoning one for the other, but in listening to the lesson the dying qanats are struggling to tell, a lesson about the true price of taking more than the earth can sustainably offer. These silent rivers of history are now being recognized not just as relics, but as irreplaceable chapters in the human story. In a powerful acknowledgement of their global significance, organizations like UNESCO have begun inscribing major qanat systems, such as the Persian Qanat in Iran, onto the World Heritage List. This designation is more than a plaque on a wall. It is a commitment to safeguarding a hydraulic heritage that belongs to all of humanity. The inscription protects entire landscapes, from the mother well in the mountains to the fertile gardens at the tunnel's end, recognizing the qanat as a complete, integrated ecosystem of technology, culture, and community. This global recognition acts as a shield, helping to defend these fragile networks from the encroachment of unchecked development or the simple neglect that comes from being forgotten. It signals to the world that this is not merely old infrastructure, but a monument to a different kind of intelligence, one we desperately need to remember. Preservation is a task that operates on two parallel levels, the tangible and the intangible. The physical work is monumental in itself. Teams, often including descendants of the original Muqannis, descend into the ancient shafts to clear centuries of accumulated silt and debris from the tunnels. They carefully reinforce crumbling walls with traditional brickwork or compatible modern materials, ensuring the structural integrity that will allow gravity to do its work for another century. Each repaired section is a victory against time, a reconnection of a severed artery. But perhaps even more vital is the effort to preserve the intangible heritage, the living knowledge carried in the minds and hands of the master diggers. This is a race against a different kind of erosion. As elder Muqannis pass on, they take with them a library of oral traditions, techniques for reading rock strata, and secret recipes for mortar that withstands constant moisture. Preservation projects now actively document this wisdom through interviews, film, and apprenticeship programs, ensuring that the craft itself does not become a ghost in the tunnel. Crucially, the most successful preservation efforts are not imposed from the outside, but grown from within. They actively engage the local communities whose identity is woven into the water's flow. When villagers participate in cleaning their ancestral qanat, they are not just performing maintenance, they are reaffirming a covenant with their past and securing their future. This hands-on involvement transforms conservation from an abstract historical project into a personal act of stewardship. Furthermore, these initiatives are increasingly linked with sustainable tourism and education. A carefully restored qanat, with a visitor center explaining its principles, can become a source of local pride and economic benefit. School children can stand at the outlet and feel the cool air rising from the tunnel, learning about gravity and geology through a direct sensory connection to history. This model shows that preservation does not mean putting something under glass. It means keeping it alive and relevant, allowing it to teach and inspire. Ultimately, preserving a qanat is about much more than saving an old tunnel. It is about maintaining a living dialogue across time. It honors the ingenuity of ancestors who, with simple tools and profound patience, negotiated a peace treaty with a hostile environment. But more than that, it preserves a working model of sustainability that speaks directly to our current planetary challenges. In an era of climate crisis and resource anxiety, these ancient networks demonstrate that resilience is found in balance, in decentralized management, and in technologies that work with natural forces rather than overwhelming them. Every qanat that continues to flow is a testament to a different possible relationship with the world, one built on foresight, cooperation, and deep respect for the limits of what the earth can give. To ensure these silent rivers continue for future generations is to preserve a wellspring of hope, a concrete example that our own path forward might be found not only in inventing the new, but in remembering and reviving the timeless wisdom buried just beneath our feet. The story of these hidden rivers is ultimately a story about time. It asks us how we measure a civilization's success, not by the height of its towers or the reach of its armies, but by the endurance of its foundations. For over 2 millennia, the silent, patient flow of a Qanat represented a different kind of ambition, one built on foresight rather than force, on balance rather than brute extraction. These networks were indeed the arteries of desert empires, but their pulse was a quiet one, beating in time with the natural recharge of the earth itself. They enabled more than just survival. They created the possibility for art in Petra, for philosophy in Palmyra, for caravans to carry silk and ideas across continents. They wove intricate social contracts around shared water rights, proving that fairness and cooperation are not abstract ideals, but practical necessities for enduring community. And they reflected a spiritual reverence, a sense that water was a sacred trust to be guarded with both prayer and precise engineering. Today, as aquifers sink and rivers run dry, their lessons echo with new urgency. They demonstrate that sustainable engineering is not a modern invention, but a recovered ancient wisdom. They show that resilience is often found not in complex, centralized systems, but in decentralized, community-managed adaptation. Most importantly, they challenge our assumption of dominance over the natural world. The true legacy of these tunnels is a philosophy of collaboration, a reminder that our greatest achievements come from working wisely within the limits of our environment, not from exhausting it. The stones and slopes of these hidden channels ask us to think in generations, not quarterly reports, to value continuity over conquest. In their cool, dark passageways lies a blueprint not just for managing water, but for building a future that, like the Qanat itself, is designed to last. If this journey into the hidden architecture of history has sparked your curiosity, please consider subscribing for more explorations of the past. We would love to hear your thoughts on these ancient marvels in the comments below.